Exercise 7.3, question number 5. We proceed doing problems based on normal distribution by standardizing the variable z equals x minus mu by sigma. As we read out the problem, let us identify what is average, that is mu, and what is standard deviation, that is sigma, and what does x represent. From the last line of the question, I can identify what is x. As we read the fifth problem, in a test on 2000 bulbs, so capital N I can call 2000. That I will multiply in the last step. Certain bulbs, the burning hours, following normal distribution. Average life, so this tells me it is mu. So 2040 is given as average, so I can mark it as mu. Standard deviation 60. Standard deviation I will mark as sigma. Estimate the number of bulbs likely to burn. So likely to burn. So the burning hours we will take as x. First question, more than 2150. So x greater than 2150. Less than 1950. X less than 1950. More than 1920 but less than. So x is between 1920 and 2100. So this is the problem. As I read line by line, let me identify all this and proceed with the problem. So we have written capital N, the total number of bulbs which we will use in the last step. Mu, as we understand from the question, 2040. Sigma, it is 60. X follows normal with parameters mu and sigma square. Z is the standard normal variable. The formula is x minus mu by sigma. My first question is probability of x more than 2150. What should I do? In this formula, wherever x is coming, let me put 2150 minus mu value 2040 divided by 16. So whatever answer we get, we have to put it. 110 by 60. Use calculator and get the decimal. We get 1.83. We will substitute in the given question. X greater than 2150 is rewritten as P as it is, bracket as it is. In the place of x put z. Greater as it is. Instead of 2150, we will write 1.83. The question is about x. We transformed into z. So z value I have to write. Why do I write z value? I can refer the table only with z value. Draw the normal curve. Just a rough diagram will do. See that the baseline does not touch the curve. Minus infinity to plus infinity. The middle we mark as 0. Plus value mark in the right. Minus value mark in the left. 1.83 positive mark in the right. So this is 1.83. What is the symbol? Greater. Greater tells me mark in the right side. So my question is z greater than 1.83. That is this portion I want. But I can refer the table only from 0. So the standard normal table I can refer only from 0 onwards. How to convert it? Find out 0 to infinity. Find out 0 to 1.83 and then subtract. So how will I write it? Probability 0 to infinity minus probability 0 to 1.83. What is 0 to infinity? The right of normal curve is 0.5. 0 is in the middle, 50% in the right and 50% in the left. So remember, 0 to infinity, the value is 0.5 minus 0 to 1.83. How should I see? 1.83, we will mark here 1.8 under 3. So 0.03, that is the second decimal. 1.8 first decimal here, second decimal I have to see 0.03. 1.8 under 0.03, the value is 0.4664. Subtract from 0.5 and then write the answer. This is for one bulb. As I subtract 0.0336 is for one bulb. But how many bulbs are given in the question? 2000. So, for 2000 bulbs, just multiply 2000 into 0.0336, which is 67.2, approximate to a whole number, because when I say number of bulbs cannot be in decimal. So say 67 bulbs are burning more than 2150 hours. The second part of the question, burning less than 1950 hours. So x less than 1950. Same formula, z is equal to, wherever x is coming 1950, mu is coming 2040, divided by sigma is 60. As we subtract, we get minus 1.5. The question, x less than 1950, we will rewrite as x becomes z less as it is. Instead of 1950, the value is minus 1.5. Now we will draw the diagram, a rough normal curve. Remember, the curve shouldn't touch the baseline. 0, minus infinity, plus infinity. When negative number comes, mark in the left side. So this is minus 1.5. What symbol? Less. Less tells me shade in the left. How will I find it out? So my question is z less than minus 1.5. So 0 to minus infinity and 0 to minus 1.5, subtract. What is 0 to minus infinity? I have to say minus infinity to 0. In this case, after 0 we said 0.5. In this case, below 0 also 0.5 only. So 0.5 minus, from minus 1.5 to 0. But even if negative number comes, by symmetry, I can see the positive number only. So I can write 0 to 1.5. That is 0.5 minus, I must check in the table for 1.5. So we will check 1.5 under 0, 0.4332. Subtract it, multiply by 2000, get the number of bulbs. We get 0.0668. This is for one bulb. When I say for 2000 bulbs, multiply by 2000 and round up the value, because number of bulbs cannot be in decimals. Proceed on to the third section. Probability of x between 1920 and 2100. As before, x is equal to 1920, z is equal to 1920 minus 2040 divided by 60. Every time remember that we have to substitute in this formula. Whatever x they have given, substitute it. So my answer is minus 120 by 60, that is minus 2. X is equal to 2100. Z is equal to 2100 minus 2040 divided by 60, that is 60 by 60, which is 1. Now we have to draw the diagram. Again the normal curve. What is the value that I have to do? Whenever we draw, remember the curve shouldn't touch the baseline. Minus infinity to infinity, it is from 0. As I see the question, probability of 1920 less than x less than 2100 equals probability of 1920, I will write minus 2. X, I will write z. 2100 is now becoming 1. My question is minus 2 to 1. Where is minus 2 coming? In the left side. Negative number in the left. Where is plus 1 coming? In the right side. Positive number in the right. I want z in between these two. In between, shade this area. So my question is minus 2 to 1. How will I split it? The table I can refer only from 0. So to refer to the table, split this with 0. Minus 2 to 0, 0 to 1. Minus 2 to 1 is my question. How do you split it? P of minus 2 to 0 plus P of 0 to 1. What is minus 2 to 0? Even if they give minus 2, I will check only in plus 2 because to the right, to the left, the curve is symmetrical. So minus 2 comes also. Refer the table for plus 2 only. What is my value? 0.4772. I check 2.0 under 0. 0.4772 plus 0 to 1. So now I will check under 1. 1 implies 1.0 under 0. The value is 0.3413. Adding which 0.8185, which is for one bulb. So for 2000 bulbs, multiply the answer by 2000. We get 1637. Take and write the answer. 1637 bulbs burn between, whatever is the question here, 1920 hours and 2100 hours. 133.6 tells me 134 bulbs burn below 1950 hours. Here it is already a whole number only, so no need to alter. 1637 bulbs burn between 1920 hours and 2100 hours. Exercise 7.3, question number 8, almost same as question number 5. If the height of 500 students are normally distributed with mean 68 and standard deviation 3. Heights of students. So X represents heights of students in inches. As they have given the unit, we can mention. Mean tells me mu. Standard deviation tells me sigma. This 500 students tells me capital N. So as we know N mu sigma, let us write it all. How many students high? So 500 I have to multiply in the last step to get the number of students. A part greater than 72. So X greater than 72 is the question. How to do it? What is the formula? X minus mu by sigma. When X is 72, Z is equal to 72 minus 68 divided by 3. That is 4 by 3, which is 1.33. When X is 72, Z is 1.33. Let us write the question. P of X greater than 72 is nothing but Z greater than 1.33. Draw the diagram for normal curve. The baseline and a rough diagram for a normal curve. See that it doesn't touch. we mark 0, minus infinity, plus infinity. 1.33 is a positive number, mark it in the right. Greater than tells me shade in the right. How to get it? 0 to infinity, 0 to 1.33 minus. I want the shaded portion. So the full portion minus 0 to. I can refer the table only from 0. So always connect with 0 and write it. What is 0 to infinity? I will say 0.5. 0 to infinity, the value is 0.5. Minus 0 to 1.33. Refer the table. 0.5 minus 1.3 under 3. 1.3 under 3. 0.4082. 0.4082. Subtract, multiply by 500 students and get the number of children. 0.0918. As we multiply by 500, it is 45.9, approximating 46. Take and write the answer in statement. 46 students high, more than 72 inches. The second part of the question is less than or equal to 64. So P of x less than or equal to 64. When x is 64, z is equal to 64 minus 68 by 3. That is minus 4 by 3, which is minus 1.33. The same pattern, P of x less than or equal to 64 is P of, instead of x, z less than or equal to minus 1.33. Draw the diagram. A rough diagram for normal curve. So we can mark minus infinity, plus infinity, in the middle 0. Minus tells me it is in the left side, minus 1.33. I want less, that is this portion. How to write it? Again, 0 to minus infinity, 0 to this, or I will say minus infinity to 0, it is 0.5. 0 to infinity also 0.5, minus infinity to 0 also 0.5, minus 1.33 to 0. So minus 1.33 to 0 also refer under plus 1.33 only. Even my answer is negative, by symmetry check only in positive value. So 1.3 under 3, it is the same as the previous section. So it is 0.4082. As I proceed, the same steps will come. This is for one student. What is my question? For 500 students, multiply 500 into 0.0918, that is 45.9, approximately 46. So 46 students high less than 64 inches. So that is the second part of the question. Very few problems we may get same answers. Here it is so. We'll proceed on to the third part. Third part of the question, x between 65 and 71. Put x 65, we get minus 1. Put x 71 here, we get plus 1. So the values will be from minus 1 to plus 1. I want between. So minus 1 to plus 1, this portion. How will you shade it actually? Minus 1 to 0, 0 to 1. So between values come, I want to link with 0. So minus 1 to 0, 0 to 1. So we write P of 65 to 71 is nothing but P of minus 1 to 1. That is minus 1 to 0 plus 0 to 1. or minus 1 to 0 also we refer under 0 to 1 only. So under 1.0 it is 0.3413. Under 1 also the same value. What comes for plus 1 will come for minus 1 by symmetry. So the total answer 0.6826. This is for one student, but we want for 500 students. So for 500 students, multiply by 500, we get 3413. Decimal after 1. So 341.3, approximately 341. We will take and write number of students between 65 to 71 is 341. 341 students height between 65 and 71 inches, and that is the answer. Question number 9. The developing time in a photographic industry follows normal distribution with mean 16.28. As I read mean, mu equals 16.28. Standard deviation 0.12, sigma is 0.12. Find the probability that it will take less than 16.35 seconds to develop. So it's a simple problem. We are given mu, sigma, and what is x? The developing time in seconds. How to do the problem? We will proceed. Z is equal to, when x is 16.35 minus 16.28 divided by sigma value 0.12. As we subtract, it is 0.07 by 0.12. Divide and write. 0.58. P of x less than 16.35 is nothing but P of, in the place of x put z, less than 16.35 is now becoming 0.58. Positive number mark in the right side. And what symbol? Less. Less tells me the left side I have to shade. So whenever it is less, shade in the left side. How to split it using 0? Minus infinity to 0, 0 to 0.58, add it. Minus infinity to 0 is 0.5. 0.58, let us refer to the table. Where should you check? 0.5 under 0.08. So 0.5 under 0.08, 0.2190. So my answer is 0.2190. Add and write the answer 0.7190. Those of you who find difficult to write the steps can write it directly from the diagram. The same thing, to present it in a better way, we will write the steps. P of minus infinity to 0 plus P of 0 to 0.58. Minus infinity to 0 is 0.5. 0 to 0.58 is 0.2190, adding which we get 0.7190. No total number given, so need not multiply. This is my answer. So below 16.35, the probability is 0.7190.